Thanks. So this is our presentation with Peter F. Patel Schneider about doing stuff with the Wikidata ontology that's going to have a lot of effects, we hope. And we think that it's kind of an underlooked aspect of Wikidata. So we want you to join me to explore what can be done about these stuff. Peter can't be in this meeting right now because of a scheduling conflict. So I'll be like doing the presentation and leading the discussion afterwards. Yes, I think now it's better. Yeah, so this is the abstract that you can take a close look at, but it's like detailing what we want to talk about here. But for the presentation itself, I'll start by explaining our goals a bit. So yeah, we want to invite you to expand more efforts in improving the Wikidata ontology. And what we mean specifically by ontology, and I was confused when I first heard the word because it has like a philosophical meaning and it has some other meanings. It's basically like some of the technical aspects about what everything is. So like with subclass relationships, with instance relationships, it's what's at the core of that. And I think as the presentation goes on, you'll understand it a bit better, but maybe a more different word that explains what we do. That's not technical, but maybe more meaningful would be categorization or organization or modeling. These are all things that are relevant to what we're doing. And you've probably encountered it to some aspect or another when you were working on Wikidata. So yeah, the ontology helps us organize and structure the data that's on Wikidata. And if you have errors in that, it's not only an item level local error, but a much bigger error in the end. And we use the Wikidata ontology to find information, like when we're using Sparkle and we put the little star so that we get not only the said class, but also its subclasses. That's when we're dealing with ontology directly. And yes, if we have an unreliable ontology, which Wikidata in many aspects currently has, because it's like very large and community maintained and everything, then it's not really that easy to use it for some complex tasks. And what we intend to do is to find those types of errors and to do some efforts fixing them. And yeah, for this session specifically, we want to present these information. We want to present some details. And then, we intentionally left a lot of space, a lot of time for us to actually do the discussion. So the presentation will be relatively short within the time frame, and then we'll get on to discussion. So if you have anything specific that you want us to talk about or you want to bring up, please start considering that right now so that when the time comes, you can do that. So like we've intentionally left that space. So let's talk a bit about the history of ontology issues on Wikidata. It has been like an ongoing topic for some years now. And I've joined in like a very recent time when I look at these dates right here. There are some links here that you can look at when we upload the slides. And yeah, I think also Wikimedia Deutschland has focused on this to some extent, and this subject has been brought up in some other conferences as well. And yeah, the current status is that there's lots of heat and not much light here, which is like, there are a lot of discussions, there are a lot of like solutions, proposals, everything, but nothing really gets to the bottom of the issue as much as we'd like. And perhaps one of the reasons is that we don't really have a dedicated group that's big enough to tackle these subjects in that way. And yeah, the community isn't necessarily aware of these issues, or if they are more aware in specific aspects. So if you go around Wikidata and ask people, oh, you're modeling like music or politics or sports, what are the problems that you face? Like you might hear, oh, I'm putting like people in the bands that are in the music groups and I'm putting in the genre, but somehow it doesn't end up working when I run a query. And many times the issue is actually an ontology-based issue. So when we get serious about it and when we try to tackle what's going on, here's what we're trying to do. One of the things is that it's really easy to find problems in the Wikidata ontology. So when you log on to Wikidata and you surf around a little, you click on a few links, you will probably find within a few minutes many errors. But then it's not that easy to systematically find them. Like when you see an issue and you make an abstraction, oh, this happened because of that. I want all of the errors that are in this pattern. That's also possible, but not necessarily so easy. And fixing them is even harder sometimes, because when we want to do something, sometimes a single update can fix many problems at once, but it's the getting to that specific problem that's one of the harder issues. So we do some like different algorithms and different stuff that gives us the effect of exactly what's going on. So one of the examples is if there's a disjointness violation that affects like 2-3 classes, that's also an issue, but there are sometimes disjointness violations that affect like thousands of items at once. So fixing that is kind of more important, even though it's still one edit and only one fix. And yeah, I want to show 3 examples. One of them is Benifer. So that's the ship name of Jennifer Lopez and Ben Affleck. And someone modeled this and made instance of links to Jennifer Lopez and Ben Affleck. So this means that, oh, what is Benifer? Benifer is Ben Affleck, or Benifer is Jennifer Lopez, which is obviously wrong to us. It's not an instance relationship. But someone just made a mismodeling like that. So one of the results of this is that humans then skip the class order. So when you look at Wikidata holistically, there, like, the issue really creeps in and becomes a much bigger issue. So what we should do is just like remove these links or make it has parts relationships or something like that, and the issue is fixed. But this is a very local issue, and even though it may have a big effect, it's just you fix the issue and then you move on. It's not like a systematic thing. Oh. Something else that's maybe a bit more systematic is that gene, like the genes in our body or the genes that stem from DNAs, are a subclass of these 3 things that you see on the screen right now: nucleic acid sequence, biological region, and biological sequence. So there is the issue here that sequences are abstract. Like when you have a sequence of numbers, 1, 2, 3, 4, whatever, that's an abstract notion. But a biological region may not be an abstract notion. It may be a concrete thing. So there ends up being a disjointness violation near the very top. So this means that we won't know necessarily if gene is abstract or concrete. So to fix this, we had to have a lot of philosophical discussions. And I don't know that we've fixed it completely, but it's still in our radar. And something that's maybe a lot more effective in a bad way, that like afflicts a lot more items, is the item organization. So we have this subclass relationship that an organization is a subclass of like a group of humans. And this is true for some organizations. Some organizations are made up of humans, but for some, that's not really the case. Like when we look at the United Nations, it doesn't have people as its members. It has countries as its members. Maybe indirectly, you could argue that it's a group of humans, but there's a really weird modeling decision made there. So we wanted to fix this, but when we did the fix, some people objected to it for their own reasons, because they were using it for something else or stuff like that. So what needs to happen is that the community has to have a discussion around this and to move forward with that. And yeah, finding individual problems. Yeah, I just basically listed the things that we wrote here, which is like sometimes it's a local issue, sometimes it's a more general thing, and sometimes it's much more of a systemic thing, and I'll get to that further. So things like this is like, it makes Wikidata more into a semantic thing where you see a statement and you say, oh, this makes sense. But then when you move it to a logical front, it may not necessarily make that much sense. And yeah, for fixing some individual problems, it's not always clear what the best fix is. You may need to contact someone who knows a lot about the Wikidata ontology and how to find such a person. Of course, you can write in the Telegram groups or in the Wikidata like community chat and stuff like that. But this sometimes makes it so that you have to have a whole conversation with someone before doing the fix. Or sometimes someone may know a lot about the Wikidata ontology, but they wouldn't necessarily know about the domain that they're working on. There are very specific domains with their own classification rules, and Wikidata will try to reflect that. And that's also difficult. And also there can be resistance, like because some people or tools might depend on the incorrect modeling, or maybe a different modeling, not necessarily incorrect. There may be different approaches, or the modeling may be oversimplified. It may be telling the truth, but in a way that's not really that good. And the fix that you do may also not be perfect. It's like improving when you're doing the fixes, but it's not getting to a perfect point. And yeah, what we do in order to systematically find the problems, it's so the first thing that happens, and it sometimes happens even just naturally without looking to do this, you get curious and you start exploring. You click on the random item, or you find something you're interested in and jump through links and everything. And then you see an issue, and then, or like something interesting that you would want to work on. And then you're like, oh, why would this happen? You try to analyze the situation. And then you go onto the Wikidata query service or something similar, and then you run some queries. And sometimes it is the case that the Wikidata query service times out if the query is too complicated. So what we have done in the past is like write a Python program that sends many queries iteratively and then gets the results. And then you can explore some of the other tools such as quick statements or OpenRefine that are useful. And then you try to document and report what's going on to share the results you found with the community so that you can work on a fix together. And the fixing effort would be like you categorize the problems, you find the solutions that would make sense. Maybe you fix the modeling, or you try to do something in a batch edit. You can use OpenRefine or quick statements, as I said. And sometimes there are some exceptions that you would see. And for them, if they're not too numerous, you can just manually handle them. It's okay to do that. Sometimes we have this mindset of, oh, I must automate everything. But if the manually handleable ones are not too much, then yeah. So what we have done, according to what I've explained here, is we've done a systematic effort to find disjointness violations. So that's when a class or when an instance or a class is subclass or instance of two different things that should not have anything in common. That's a violation if it's technically does on Wikidata. So we made a list of them, and we are still working on fixing them. And yeah, as I said about like high effect or low effect edits, one of the updates we did, I think it was on Gene, fixed about 3/4 of the issues. So sometimes you have to prioritize what is the biggest issue that you're dealing with. We systematically ran queries to find class order problems. So that's like if something is an instance of something, and then that is an instance of a class, and then that's, etc. So class order is a complicated thing. I won't get too much into it, but it's also an ontology issue. What we've done community-wise is that we've set up the ontology cleaning task force, and then within that task force, we're having weekly meetings on Tuesdays. So I would invite anyone to join that too. There will be a QR code at the end of the slide in case you want to join. And then we ran the Wikidata Ontology course, which was a really great effort, I think, because it resulted in a lot of people who had their own issues that they were working on Wikidata, adopt an ontology-specific mindset around them. So we really enjoyed that. And yeah, what we want to do and are continuing to do is establishing communication with different people across different domains. Because as I said, sometimes it's not a Wikidata structure issue, but a general issue. And then, yeah, something that we're doing and I'm doing right now is introducing Wikidata efforts in conferences. And yeah, when we want to make a list, perhaps we could have made a bigger list, but about what information and tools are available. There are the Wikidata usage instructions, which we're also working to improve. There's a classification script that TomTom wrote that I still run. I think you do it's like doing the JavaScript thing on your profile. Most of you probably know about that. That detects disjointness violations whenever they appear. And we have kind of a love-hate relationship with constraints because they're really useful in some ways, but sometimes they don't go far enough in exploring what needs to be explored. So we haven't really found any ontology constraints that are really specific, but in case anyone knows about them, please let us know. And about what can be done in the future is to have more people working on this types of issues, building better tools so that we show the situation within the ontology. And also something specific that I'll also get into within the discussions is to change the community culture to place more emphasis on better modeling, and also to place more emphasis on fixing problems instead of adding new stuff, which adding new stuff is great. I hope we all keep doing it, but also fixing the stuff that's already on Wikidata is a very worthwhile effort. And yeah, we're trying to publicize Wikidata-related efforts in non-Wikimedia spaces because Wikidata kind of has a bad reputation in some places of not being reliable, not being useful. But when people get to know it a bit better, they may change their minds, or they may try working on it to fix what's currently here, because I believe that it's a lot more useful than many people give it credit for. So yeah, we want you to help us with expanding more efforts to revive the Wiki project ontology, which we have done some efforts in, to join the ontology cleaning task force, to agitate for better ontology tools, discuss if your current or potential efforts would benefit from an ontology perspective. And I think that the answer is most likely yes. So whether you're working on people or books or movies or music or whatever, if you haven't adopted an ontology-based perspective yet, I think that you should definitely explore it because there are a lot of opportunities there. And something that I want to talk about more immediately is that we're trying to set up a Myriology task force. So you will have seen on Wikidata that statements have like part of statements or has part statements. These are not great right now because when you look at them, as I said before, they make semantic sense. So when you see like, oh, book has cover, pages, back cover. Okay, this makes sense to us. That's a physical part to the relationship. But also when you look at a movie, it says like, has parts, intro, outro, something. I'm just making these up. These aren't like actual statements, but I'm giving them to give my point. That's not a physical relationship. That's more of like a conceptual relationship. Or maybe Wikimedia has parts, Wikidata, Wikipedia, Wikimedia Commons, etc. That's not a physical relationship at all. That's more of an organizational thing. And what we want to do is to set up a task force to tackle these problems systemically and then document like what the has parts relationship currently means, how we can disambiguate these sorts of differences so that it doesn't only make sense like semantically, but it also has like a logical, firm meaning. So I will also invite all of you to join that. In case anyone is interested in this, please reach out to me later on. So we're getting to the discussion part, I think. Some of the questions that I'll ask openly and then we'll ponder about them later is that what's the most important issues to fix? What can be done to fix them? What can be done to reduce future issues so that when we're going forward, we don't create as much issues so it becomes an unhandleable situation? And specifically, what will you do specifically? And how can we help you is also something that I'll ask. So thank you for listening. I don't know the time yet, but I'll stop sharing right now. We have some questions that we can raise, but in case anyone had anything that they want to share, I invite you to do that, and we'll spend the rest of our time with the discussion. So yeah, Daniel Antal, please take the stage.
Daniel, if you're muted, we don't hear you.
No. I just wanted to wait until the well-deserved round of applause will stop. So, well, thank you very much. It was a very, very super interesting presentation, and I, in the meantime, already signed up for the task force. I wanted to bring up two ideas. I will also say that I can participate in them, which goes in a slightly different direction, but I think they can really help in two different ways. So, the ontology is not only about classes, it's also about relations. And I think that, well, we have a lot of problematic classes, and we also have a lot of problematic properties. And so one idea that I think came up in these presentations, also mine, but others, is, well, people would like to find public domain or open knowledge things. And I think that the way currently rights are described in the model are extremely simplistic. And for example, such a great tool as just we saw, the Paulina, could work a lot better with basically better describing what is allowed to be done with something or not. So I think that's an example where I think it would need better classes, but also better properties. And I would be very happy to participate in that. And the other issue is a bit more philosophical, but I think it's important. We had a very nice presentation earlier about lexemes. And I think that a better integration of lexemes would be great, because I think that a lot of the issues that you're bringing up about problematic classes are probably because of problematic linguistic misunderstandings. So people create similar classes that they don't really feel that it means the same. And I think that, or they have bizarre translations. If you're looking at the class definitions in different languages, which I often do, then things get really confusing. So I think that also thinking about how you name a class and how you describe it better, and therefore a little bit better integrating lexemes and linguistic information would be also super interesting.
Yeah, I definitely agree that sometimes there are issues of like classes being misnamed, or sometimes, yeah, even linguistic issues, because different words that should correspond to the same concept may not practically be that. Something I like as an alternative, let's say, is to have like external links and some maybe logical definitions of what everything is, so that like when we say subclass, it means the same thing for everyone, hopefully. But yeah, with some classes, we definitely do have these sorts of issues. But sometimes we also have issues that are not linguistic specific. So we just have like something that happens somewhere that results in a logical contradiction. That's when you query for it is easy to see, but you wouldn't see when you log on to the page. Because I think with Wikidata, when you log on to a page and like you look at it from top to bottom, most information there will seem correct most of the time. But when you do a sort of logical inferencing with steps and everything, then that may become a problem. But yes, so thank you for bringing that up. And if anyone wants to chime in about this subject, please raise your hands and we can continue like that. Yeah, so Stefan, thanks.
Can you hear me?
Yes, we can hear you.
Thanks for your great presentation as well. Actually, I just want to say that your talk made me realize something, that I've been approaching Wikidata from what I thought was the obvious angle, but apparently it's not that common. So I've been treating Wikidata as an ontology that's perfect for automatic reasoning and inference rules. And this is exactly what my tool does. and I'm new to the community, but I got a rapid fund for this. I just want to express that all the other talks prior to your talk made me open my eyes to all the different ways people use Wikidata. So I was completely focused on this logical consistency aspect of Wikidata. And well, I just want to say I'm grateful that Wikimedia Rapid Grant, so Wikimedia is supporting my work, and it's very interesting to hear all the different perspectives on Wikidata. I thought the ontology aspect is really the only one, but I learned that it's far from true. Yeah. Okay, thank you.
Yeah, and thank you for saying these, because I agree that when you focus more on ontology, which some of us do, yes, it's also really nice to see that when you look at a domain specifically, then that actually reflects on your thoughts about ontology as well, because maybe you see something about modeling that you hadn't considered before. Maybe you see something that you thought was very simple, but it's actually more complicated. I'm actually experiencing something similar now, because I'm like working a bit on books and like library type things, which is like it also affected my thoughts on modeling and ontology. So I think my presentation was mostly about getting people who are not involved in ontology to get into ontology, but it could also work the opposite way of like, if you're only interested in ontology or primarily interested in that, maybe you should start exploring and look at some other domains as well. So thank you so much for bringing that up.
Thank you.
So if anyone wants to raise some points about this or something else, please take the stage. Yeah, Lydia.
Yeah, thank you for your excellent presentation. I have two things. One is maybe not everyone has seen this yet, but just recently Markus Krutsch published a new thing for that might be helpful for finding issues in the ontology. So people interested in ontology questions should definitely have a look at this. It's called Nemo. And the second thing, you had a list of things that people should do, or what can we do? And I think one thing that is missing on this list is more reuse, because the more the data is used in specific contexts and so on, the more there's a pressure to properly keep it stable and model it consistently and so on. So encouraging more people to build with specific parts of the data in Wikidata can definitely also be a helpful force.
Sorry. Okay, can you hear me right now?
Yes.
Okay, thanks. So when I clicked on unmute, it didn't register, so I re-clicked and then it's muted again. And yeah, so I definitely agree that reusing Wikidata and making it more like practically used is a great way of maybe shining light on these issues and fixing them and improving Wikidata. But in that, I believe it's kind of a two-way street, in that many people who would want to reuse Wikidata are staying far from it, because like they know that the current information may be problematic, but the current information is not as problematic as they think most of the time. Like when we look at Wikidata as a whole, of course, there are many problems, but some domains, some specific things are modeled really well. Like, for example, I would trust like birth dates of humans and death dates and whatever on Wikidata, like really a lot. So if I was building something about like, oh, who was born when and who died when, like a timeline, I would use Wikidata, no questions, because even if it has some errors, it's not really a deal breaker. So yes, I believe that some of the publicization work is about encouraging reuse. So thank you for bringing that up.
And maybe that is a two-way street that we're saying, right? And I think Gap Directory is one great example where they built a tool and are now encouraging people to clean up data that they care about for their country or whatever it is, right? And model it in a very specific way so it can be picked up by the tool. And I realize that this is not a thing that can happen for every part of the data, but I think that's a really, really good example.
Yeah, thanks. And if anyone wants to bring anything up right now, feel free to raise your hand or unmute yourself and speak.
Anyone? Any last points for the ontology discussion?
If not, maybe I can ask like a really specific question that's going to keep us busy for some more minutes. Can I? Or, yeah. Which is like kind of an elephant in the room situation for all things technological at this point, I think. How would we use AI in this, and should we, and what do we need to do about it is one of my questions. So one thing I have in mind is that when we look at the disjointness violations, for example, that I have like a CSV file of like 10,000 items or something. So before maybe AI itself, we could use some machine learning on them to put them into categories and move on from that. That's definitely something that I'm planning to do in the future. But also, would it be a meaningful task to list some issues and then ask an AI program that's maybe specifically designed for this to categorize them and to propose new solutions and everything? So what I think would be that the last touch should always be human. Like AI could give us suggestions, but when we're committing all those changes, the last step should always be done by a human, or maybe not always, but most of the time. So that's something I have in mind. So I think Stefan raised his hand first, and then we can go on to Daniel.
So thank you. Well, to address this question, I think it's very important to distinguish between the modern AI, like LLMs, and the classical AI where you examine ontology. So you can do a lot of stuff without LLMs, because you can, Wikidata is formalized knowledge. So there are a lot of reasoning which you can do. I don't know if you remember, there was an old project in the US named Psych, which was funded by Microsoft. And this shows, I think it's even online even now, so it's open Psych. You can do a lot of stuff with classical inference mechanisms, and you have to distinguish with LLMs. You can do other things with LLMs. Of course, you can also do useful things with LLMs. But I think Wikidata it's very obvious to first try to use classical inference mechanisms on this, which is what I'm doing. But yeah, I just want to draw your attention to this important difference between two completely different mechanisms to do automated reasoning on Wikidata. This is all I want to say at this point. Yeah. Okay.
Yeah, Daniel, go ahead.
Yeah, I think that Stefan just said one of the things I would have said, that I think that once you use these more classical forms of AI, first of all, I think if you use those tools, some of these problems will come out that we're addressing here. the other thing I wanted to say is that well, so the way I work is that I try to build Wikibase instances that more or less reuse the Wikidata ontology, but when they don't work very well, then I just define something else. I think this could go actually hand in hand. So before you make changes in the Wikidata model, have a big Wikibase instance, try it out, try reasoning, try querying, and see how it works. And when I'm doing this, I usually use LLMs just for consistency checking, or sometimes what I do is that I try to translate to a different ontology what I described here. So I work mainly with cultural domain, and I try to express it in CDOC. Of course, it's a very different ontology, but I think that using all kinds of AI has a very important place in nowadays work, kind of software engineering, and this is also a sort of software engineering. And I agree with you that the final word should be with humans, but I think both the traditional forms of AI and LLMs can be incredibly helpful to spot things that you wouldn't really see in the first place. So yeah, I think we should, absolutely.
Yes, Vivian.
Yeah, hi, I hope you can hear me. I just wanted to say thank you, first of all, for the presentation. And maybe it's just adding to what Daniel just said. Because in my master's thesis, I created a Wikibase and an ontology for theater plays because I didn't find it in Wikidata, because I was kind of scared to do it in Wikidata itself. And then I had the question, like, how do you weigh up which changes of ontology make sense and which don't? Because I have the feeling the more you abstract or generalize ontology, you kind of further away from it, from the ontology itself. And I was asking myself, do you consider it case by case or on a case basis, or do you have like some rules, or how do you find the right balance? And when you asked the question about AI, I thought maybe AI could find similarities between problems and between asking the questions when to change an ontology and when not to. And I'm kind of having a hard time to find out for myself when it makes sense to change the ontology or when to say, okay, I don't change it, we just have to do it differently, but stay with the ontology I made. I hope it was clear what I was trying to say.
Yes, definitely. Like, we also have that problem of like, oh, so we're trying to represent some nuance here, and is the current system good enough to represent it? Or maybe should we forego some of the nuance, or should we like go to the system and somehow change it in order to fit what we want? And on Wikidata, one of the things that you have to do that is to maybe propose a new property that's like not in the current ones, and that's a whole process that's I find really difficult, but maybe it makes sense for it to be difficult so that it's not like we're overcrowded with properties. So yeah, I believe some of the decision making on that, like, it's of course a community decision whether to go forward with making it more complicated or to keep the current thing, but to explore what's the possibilities are and what the literature says about these things is something definitely that an LLM could tackle, and maybe even better so in the future than currently.
Thank you.
Are there any more questions in the audience? Jorge, please go ahead.
Yes, this is just a question because you raised the question about that creating properties is a quite difficult process, but it's also true that, but I think, if I understanding well, that creating classes or subclasses of some classes, it's quite easy. So we have because it's just marking an item as a subclass of another one. So this kind of design of Wikidata has some consequences. Am I understanding right? What do you think about this?
So you are definitely right that the subclass relationships are one of the most central thing in the Wikidata tree. Like on the very top is entity or thing. So that includes everything. And then you go to like different axes of differentiation. Like there are the concrete objects, there are the abstract things and stuff like that. And one of the important things in building that tree is that subclass relationships are transitive. So if like A is subclass of B and B is subclass of C, then you also have the link from A to C, which may not be on Wikidata directly, but you infer it. And one of the most important aspects of our work with ontology is based on that, but it's not only limited to that. So did I understand your question correctly?
Yes. Because I was just wondering about the impact of this. That this is very easy to put one item in that tree, but it's very difficult to create properties, and this has some. I think it has some impact in the way that describing knowledge. That you can describe knowledge in Wikidata. So people may be more, may think it's easier to go that way of describing better things through adding them to subclasses of other things that making the effort of creating new properties.
I definitely agree. Like maybe classes, or at least some high-level classes, are as important as properties, but for them you don't need like a community process, so it's much easier to do that. And something that I've seen many times is that whenever something doesn't have a property, but the people don't want to go through that effort, they just use has characteristic and then put whatever they want. So that's definitely a Wikidata specific thing, I think. And yeah, I agree that like the process of creating classes being this easy and for properties this difficult is definitely having a real effect on how Wikidata is. And I'm not saying that the effect is negative or positive per se, but it does shape what Wikidata is.